Okay. So what we're going to do is alternate the phosphates and the sugars. And each phosphate, along with a sugar, and one of the nitrogen bases represents a nucleotide. And I'm just going to string them in alternating. When you cut these Twizzler pieces, you have to make sure you open them up so that you can see them. And I'm not doing a full ladder, even though our students will be doing a full ladder. I'm just showing you how to do this. Remember, this is the sides. And a ladder has two sides, and so you may have to use a if it's hard to get your little string through, you may have to use your toothpicks to get them through, but it's working. How about we do two more? Remember, these are the sides, alternating the phosphates and the sugars. Okay, let's get that phosphate on. Almost. Gotta pull that through. And some of them may be a little hard. There we go. And one more sugar. And DNAs are exactly the same side on two sides, so we need 1, 2, 3, 4 more sugars and 4 more phosphates. So we're going to go ahead and do the other side of that ladder. Okay. And a phosphate and a sugar and a phosphate and one more sugar, and then we have the other side of our ladder. And hopefully everybody can see this good. Both sides of the, oops, what are we missing there? Okay. Oh, we need 2 more. That other phosphate on. And just pull it that way a little bit. You might be wondering why we have these gumdrops here. Well, when we gave our students all of their tools, we wanted them to be creative. We didn't want to tell them exactly what they need piece by piece. So we wanted them to be able to determine if they use gumdrops or what have you. So we don't want everybody to be looking the same. We're also going to have some marshmallows, but today I don't have those. We're going to have some colored marshmallows. So here we have, and I can actually move our phosphates out of the way. And our sugars over there, phosphates over there. And we now have our 2 sides of the ladder, okay? Now, our nitrogen bases are only attached at the sugars. So we have sugars, phosphates, sugars, phosphates, sugar, phosphates. So at the sugars, we're going to attach our nitrogen bases. And we have to remember that adenine only attaches to thymine. So I'm going to use my toothpick to attach my nitrogen bases on. and then they attach to the sugars. So every time I see a red, I ought to see a green, because the A's and the T's attach together. And I'm going to put that through there, and put that through here. Okay. Okay, and then I'm going to have a cytosine and a guanine. And actually I can go ahead and do all of those. I'm going to need 1, 2, 3, 4 nitrogen base pairs. Now going down the DNA ladder, okay, I'm just going to hold it up a second so we can see what it's looking like. Okay. Now, when we're looking at DNA, the way our nitrogen bases attach, actually, when we take a little segment of it, tells us about the genetic traits of a person. So even though I'm alternating like adenine, thymine, and then I'm going to do the guanine and the cytosine, when a person, a scientist, reads up and down here, they can tell the adenine, guanine, thymine, that this little strand right here represents a particular trait of a person. So, you know, DNA is so amazing. It's so amazing. It's actually the blueprint for life. So, I'm going to attach those. Attach these. Now to keep my sugars from, actually they won't fall off once we have all this attached, but what I could do to keep that from falling off is to go ahead and tie it on between one letter. No, I'm actually going to like that. Oh, I guess we can tie it like this. We know that's not the case though. We just don't want any of our sugars or phosphates to fall off. Okay, so you gotta pretend that's not there. Now remember, these nitrogen bases are being held together by hydrogen bonds, which actually hold the nitrogen bonds pretty loosely, because when DNA replicates, the bonds actually unzip and allow one strand to be replicated to form a whole nother strand of DNA. Okay. Remember, guanine only attaches to cytosine. And where we have the guanine on this side, this time we can have the cytosine and the guanine on the other side, as long as they're paired up properly and we're consistent with that. Okay. So when we do this in class, actually, we're going to have 9 rungs of the ladder. Right now, I only have 1, 2, 3, 4 rungs of the ladder. But you get the hang of what I'm doing here. And once the students are all done, we'll stand it up. And remember, we said that DNA is just not like a straight up and down ladder. It more looks like a spiral staircase. So let's see if we can't give it a little twist to get that double helix look. Okay. So you see that? Look at that. Isn't that beautiful? Okay. And our students will be longer, and then they will have a chance to explain on camera why they chose the pieces that they chose, and what each piece represents, and how this activity helps them to understand the molecular structure of DNA. That's beautiful. And at the very end, they get to eat their DNA. Yeah. So is this good? Okay. Can you press the red button for me, please?